Continuing with section 2.3, we introduce some trig derivatives, and this section has 6 more derivative rules to memorize. What I kind of did was put the derivatives that were positive over here on the left, meaning that derivative of sine, positive cosine, tangent, secant squared. Secant is going to be secant tangent. And the negative derivatives over here on the right side. So cosine is negative sine, cotangent is negative cosecant squared, and then cosecant is negative cosecant cotangent. So we have to include these 6 new derivative rules along with the previous derivative rules to find more derivatives. So first example is going to be to find the derivative to differentiate this. And since this is a product, I'm multiplying x squared times cosine. I have to use still the product rule, which is f g prime of g f prime. So to kind of start off, I label accordingly. I know this is going to represent f, and this is going to represent g. But from there, it's just a matter of following what the rule says, which will be f prime equaling x squared stays the same. I'm going to multiply by that the derivative of cosine, which we just said is negative sine, plus this time cosine stays the same. I'm going to multiply that by the derivative now of x squared, which what the power rule says is going to be 2x to the first power. If you drop the power in front, subtracted by 1. And then simplifying this a little bit, I can say this is going to be negative x squared sine of x plus, I can just put this 2x in front of the cosine, and that's going to be my derivative. That's going to be my answer. Alright, so now moving on to the next example. I want to find the derivative to this weird looking expression. Now notice this, I have 3 times secant minus the product of e to the x cotangent x. Since I'm subtracting 2 separate quantities, I can find each derivative separately. So I can go y prime is equal to the derivative of 3 secant minus the derivative of e to the x cotangent x. I can separate these two based on one of the properties we learned in the previous section, which said you can split each individual derivative. This is just the constant multiple rule, so I can multiply 3 times the derivative of secant, which is secant tangent, minus, now because I'm multiplying e to the x times cotangent of x, I have to use a product rule on this piece of it. So the product rule on this is going to be e to the x stays e to the x. Now the derivative of cotangent is negative cosecant squared plus cotangent stays the same, and the derivative of e to the x is itself e to the x. So this big parenthesis is the product rule on e to the x cotangent x. And a little bit of simplifying I can do. I can say y prime is going to equal 3 secant x tangent x. This negative multiplied by that negative is going to be a positive e to the x cosecant squared x, and this negative distributed to this positive is going to be negative e to the x cotangent x. and this weird looking long expression is my derivative to the initial problem. Alright, last example is going to be finding a tangent line equation to the function tangent at the point pi over 3 comma square root of 3. For these tangent line problems, the very first thing I have to do is find the slope. So the way I find the slope is by finding a derivative. So y prime is going to be the derivative of tangent, which is secant squared. Now that I have my derivative, to find the slope, I have to evaluate it at the point. And I just noticed that instead of x, I should have used theta, so secant theta. So evaluating pi over 3 is going to be secant squared of pi over 3. Anytime you have a trig function that's squared like this, I have to evaluate it first and then square it. So I got to figure out what secant is at pi over 3. Well, secant x or secant theta is the same thing as a reciprocal of cosine theta, and cosine of pi over 3 is equal to a half. So if I reciprocate cosine, I can reciprocate this 1/2, and this would just be 1/2 reciprocating would be equal to 2. So secant of pi over 3 is equal to 2. I'm supposed to square that. So my derivative slope, my derivative value, is going to equal 4. So now that I have my slope, I can write my tangent line equation. As y equal to mx plus b. I know the m is going to be 4. I know my y coordinate is square root of 3 from up here. It should be equal to. I know the x value is pi over 3 plus b, so really all I have to do is solve for b. So square root of 3 is equal to 4 pi over 3 plus b. Now, this is not going to give me a nice whole numbered answer or a nice fraction. It's going to be some bizarre expression, but I can still solve for b by moving this over. So square root of 3 minus 4 pi over 3 is what b is equal to. And I don't really care to simplify this very much, so I'm just going to put my tangent line equation as y equal to the slope, which is 4 from the derivative value, x plus, and I'm going to put this all as my y-intercept, plus square root of 3 minus 4 pi over 3. And this weird looking thing is my tangent line equation at the point pi over 3 to the function tangent. And that is it for this video.